Hello everybody and welcome back to Chapter 2 of the Introduction to Python course. Now in the first one we talked about just computers and programming, and now what we're going to be doing is we're talking about actually digging into the programming language, the Python programming language, and we're going to be talking about how we do input, processing, and output. So specifically we're going to be talking about first about just how we design a program. After that we're going to be talking about input, processing, and output. We're going to be talking about the displaying output with the print functions. We talked about that a little bit last video. After that, we're going to be talking about what comments are, what variables are, how we read keyboard input, how we perform calculations, a little bit more on data output, what named constants are, and then we'll also talk about introductions to the Turtle Graphics library. So to begin, before we can start building anything, we need to ask ourselves the question, how do we design a program? So programs are designed using the following cycle. The first thing is we design the program by first writing we design it, then we write the code, we correct syntax errors because you always have syntax errors. Then you test the program, you correct for logic errors, and you test it again. You keep going with that cycle until it's correct. So what we mean by this is that, again, when you're dealing with a program, there's two different types of errors. There's either syntax errors or there's logic errors. So when you're designing a program, you first design what you want it to do, you write the code, and because you write programs, and as they get longer and longer, the odds of a syntax error occurring will be higher and higher no matter how good of a programmer you are. You correct those, and you test your program. Once your program runs, you need to make sure it runs correctly. So specifically, you need to correct the logic errors. Is the math right? Is it doing what you want? Is that average over there correct? Is that math over there correct? Did the interest rate take effect correctly? You need to make sure of that. Because it's not only does the program run, it does the program run correctly. So that is the development cycle we're going to be using. So the design of the program is the most important part because we need to understand if we're working in some kind of actual, if we're working at a company, if we're working with any kind of consumers or anything else, we need to get an idea of what they actually want the program to do. We need to be able to ask them about the questions about the program details, like what do they want it to do, what kind of rates, what kind of calculations they want it to do, what do they want it to show. After that, we also need to figure out the different software requirements. Do they need some kind of specialty library? Do they need some kind of specialty functions? Again, we'll talk about that later, but again, you need to fully understand what the user or the consumer wants the program to do before you even start to build it. So after we understand what we want the program to do, we need to break it down. So again, you don't look at the program as a whole, you need to break it into pieces and solve those pieces separately. So we're going to break this program into steps, which we'll call an algorithm, which is a set of well-defined logical steps that must be taken to perform a task. So for instance, if you're baking a cake, the recipe is an algorithm. You need to make the batter first, and that making the batter is composed of multiple steps. After you've made the batter, you then have to preheat the oven. After you've preheated the oven, you put the cake in. After you wait a set amount of time, you take the cake out, you let it cool, and now you have a cake. But if you don't follow those steps, you won't have the right kind of cake or a cake at all. So before we can actually design the program, what we need to do is we need to actually build pseudocode. So as you're designing it, you're going to be writing out, okay, we need to do this step, that step, this step, that step. So for instance, pseudocode would look something like this. If we want a program that takes an average of two numbers, so we'll say average, put this back up here. So we'll say average, average of two numbers. So what it will do is we'll say we want to take in two numbers. Then we want to add them, and then we want to divide by 2. So this, what you're seeing here, is what's an example of pseudocode. It doesn't actually translate to anything directly that the computer can use. We'll need to actually put this in the syntax that the programming language will use to convert it to the machine language for the CPU. But for us, to understand the steps of the program, this is all we needed to do. Okay, so that is our pseudocode. It's just informal. Again, it's just, meant for us to sort of jot our ideas out on paper, just to make sure we have a full understanding about what we wanted to do. We also have flowcharts. So after we have our pseudocode, we figure out what we want to do. We then move over to flowcharts. So flowcharts are what we're going to be using in this class to diagram or design the actual flow of the program. So you have your oval shapes you see at the top and bottom here. You'll see start and end. Those are our terminal symbols. So when the program starts, we have start. That's where we start. After we start, you'll see there's a arrow pointing to the next shape called input the hours worked. For parallelograms, we're going to be using those for input and output. So you'll see we have input the hour worked. The next step is going to be input the hourly pay rate. The next step after that is we calculate. So when we do calculations or processes, we use rectangles. And we calculate gross pay as hours worked multiplied by pay rate. So that's just some math we're doing. After that, we have another arrow that says display the gross pay with a parallelogram. Again, another output. And then we have end. So this is sort of the flow we're going to be using for these different flowcharts. So let's go ahead and try this. So if we have this problem here, so this is a problem from the book, this is problem chapter 2, problem 7, and it says a car's mile per gallon, MPG, can be calculated with the following formula. So we have our formula. We have miles per gallon equals miles driven divided by gallons of gas used. If we wanted to create pseudocode and a flowchart that asks the user for the number of miles driven and the gallons of gas used, then following this, it should calculate the car's mile per gallon and display the results. So if we're going to do this, we'll start with the actual pseudocode. So we'll come over here, go ahead and get rid of this. I should do Control A here, like that. And what we're going to do is we're going to take this actual pseudocode. So we have our formulas, but the first thing is we're going to input, or in the, what was it again? Let's double check. It was the number of miles driven and the gallons of gas used. Oop. So we'll swipe back over here and we'll say in, and we'll say input the miles driven and gallons used, just like that. So we have our miles driven, our gallons used. Then we're going to calculate miles per gallon, which is equal to the miles divided by gas used, just like that. After we calculate that, we're going to then print the miles per gallon. So this is our pseudocode. Now, if we were actually to build this in a flowchart, which you will have to do for some of your assignments in this class, what we're going to do is we're going to go over to what's called draw.io. So if we come up here and we type in draw.io and we hit enter, it'll take us to this flowchart maker document here. From here, we're going to start with our ellipse or circle or oval of one of every sort. We'll click this, pull it up here, and we'll type in the word start, just like that. You can resize it if you want to, but this is the starting point of our flowchart. We'll do copy paste with Control C, Control V, and then we'll type in end here, and that is our end point. So then what we want to do is we want to input. So we'll use a parallelogram here, and we'll say input miles driven. Okay, so we'll do that, make it a little bit bigger, make it look a little nicer, line it up, and put another parallelogram, and we'll say input gas used, or we can say gallons of gas used, just to be a little bit more specific. Pull this over, line this up as well. Now again, when we're doing a process, we need to have a rectangle, so it's a computation. And then here we're going to say MPG equals miles divided by gas used, like that. Now we have our general structure, but now we need to connect everything with arrows. You can, if you click on a shape and you have the arrow, you can hit the plus here and move to the next shape, just like this. Otherwise, if you don't want to do that, you can always grab an arrow from over here and then connect it to your shapes as well. Just like that. Okay? So this is our flowchart. So we have our input, we have our miles per gallon. However, if you notice, we missed one thing. So if we bring this arrow back a little bit, we do need to have an output. So we'll copy this or enter another rectangle here. We'll do display MPG, and then we'll pull this guy into the flowchart, just like that. bring n down a little bit, make another arrow. So that is our full flowchart. We have our two inputs, we make a calculation on MPG, and we display the miles per gallon. So when you have your assignments in this class, this is what you're going to have to do for your program exercises. You will not have to do the pseudocode, but using pseudocode is a great approach to actually understanding the problem. All right, so now that we understand how to design a program, we can actually go into input, processing, output. So typically, computers perform a three-step process. They receive input, whether it's from another person, another computer, another input source. It receives some kind of input into a program. It performs some kind of process on the input, so some kind of mathematical calculation, whether we're doing some kind of transformation, whether we're cleaning up the data, whether we're making some mathematical calculations, we're going to be performing some kind of process, and then we're going to produce some kind of output. So this output is going to be any data that the computer outputs. So whether it's a printout, whether it's saving it to a file, whether it's actually printing it on a printer, we're going to go ahead and produce that output with the actual computer. Now, in our programs, again, it's going to get more complicated. We're going to have a lot of different lines in our code. With this in mind, we want to make sure that not just us, but whoever reads our program, us in the future, someone brand new, can understand it. So while Python commands are very readable, like while Python statements are very readable, comments are going to help us produce, or should I say, translate what we're trying to do into even more human readable terms to whoever comes after it. So imagine this. You write a complex Python program, you don't touch it for 3 years. You go back to it, you want to understand it. Comments are going to be there to help guide you through your thought process so that you can remember what this code does instead of looking at the code trying to figure out what the process was. Now in Python, the syntax for comments means that it begins with a hash character. So if we go back over to, let's say we go back over to PyCharm, again, when you open it, it starts like this. We go ahead and delete this out, and we say, this is a comment. Here you'll see it starts with a hash sign on the line, so it is a comment. So now we have this as a comment. Okay, so those comments are going to be what we say, and realistically a comment would more likely be something along the lines of get input from the user. Specifically, it might be something like get age and address from the user. Then we can have something like, let's say, determine what age classification the user is. That's our computation. And then we would print out the classification to the user. Something like that. But these are the comments that you sort of want in your program, because as we're going through it, this is going to tell you more than what the code that's going to go between these comments is going to actually say. Now we also can do that as well with what's called an end-of-line comment, which means that we've written some kind of Python statement, which we'll go through here in a second, but we've written that Python statement, and that goes at the end. So for instance, if we come in over here, and we say, get rid of these, and we say, print, this is great, we can put a comment right after that with another hash sign that says, this print statement tells the user how great it is. Again, it's just more information right after the actual Python statement, which is print, this is great. Okay, we'll go into more information on the print statement as we go. So realistically here, the question is which of these is better. So if I go to option A here, which is this is over on my personal GitHub page, if I pull this up, you'll see we have one with no comments here. So in this case, this is the actual code I wrote called the Facebook Deleter, which will go through your Facebook profile and just delete all your photos. Again, Facebook does not have a mass delete option, so if you want to clean up your your Facebook page, you just have too many pictures there, you can use this. Now this doesn't really make any sense to you. This uses some web automation library that I know. You don't know it, but I know it, and you won't really understand it without comments. This isn't very nice. However, if I go back and choose option B here and open this instead, now we have comments. So now we have things like import WebDriver library, that imports a library. We'll talk about this later. We have our mainline function here, our mainline logic that tells you what this function does. And we have different steps. So in this case, we set variables. We open up Firefox, navigate to Facebook. We search and enter the email and password. We log in to Facebook. We go to the photos page, loop through all the photos, expand them, delete, confirm. So you'll see that this is going through every photo, expand, delete, and confirm, and you know what piece of code is doing what because the comments are helping not just tell you what the code is doing, but also helping separate out what piece of code is doing what. Okay? So comments are important in this class and in general, and if you do not use comments in this class, one of your programming exercises or any actual program you write in this actual degree or any future degrees realistically with computer technology or programming, you will also get points taken off regardless. So make sure you include comments because again, it is a best practice to do so. All right, so now that we've talked about comments, we've talked about how to design programs, we've talked about how to actually input, process, output, we can start talking about variables. So variables are at the core foundation of any programming language, and they are just a name that represents a value stored in the computer memory. So imagine you have a shoebox. So you have a shoebox, and you want to stick something in the shoebox. So let's say down here we have an assignment statement. Let's say right here where we have our example here for age. Let's say our example says age equals 29. So we have a shoebox named age. It has a label in the front that says age. Inside there we put the number 29. So if we ever want to access age in the future, we know that when we open the box we'll get 29. So a few examples of variables would be, like we saw, if we say name equals Bob, like that, we can then say that shoebox labeled name has the value, in this case, the string, which is in quotes, Bob. So if I ever print that name and I run this, it'll print Bob, which means it goes in that shoebox, the one that has the labeled name, opens it, grabs the text out of it, which is Bob, and prints it to the screen. So variables are assigned using the equal operator here, which is called the assignment operator, and it will take whatever value you give it, and it will assign it, or put it in the shoebox, if you will, with that label. So in this case, name. Okay? So again, realistically here, you cannot do it backwards. You cannot do Bob equals name. You can't do 29 equals age. It has to be the variable name first on the left side of the equal sign, equals, and then the value on the right side. Okay? When we talk about functions in the future, variables are important because we can pass those to functions. We can also reuse variables as well. Again, they are critical to programming languages, so you need to understand that they are just placeholders or shoeboxes or whatever you want to call them that hold a value that we give them. Okay? So again, here are the naming rules though. For Python, remember, we have syntax rules. So variable names cannot be Python keywords. So we cannot use a variable name if, while, def, those we cannot use. There's more keywords as well. As you go, you'll find out that variable name doesn't work because it is a Python keyword. If that is the case, you cannot use that as a variable name. Okay? They also cannot contain spaces. So if you want to have first name, it has to be first name, like first underscore name. So I'll show you here. So if we want to have the variable name first name, that is not valid. But if we do first underscore name equals, that is valid. Okay? This is called snake case. We also have first capital N name, that is called camel case. Either one of those is the correct way to do it. Note in both cases they do not start with a capital letter. That is not the best, that's not actually the best practice here. We want to start with the lowercase, and if we're using camel case, we uppercase only the ones of every extra word. So in this case, first and then name is a new word. Or, in my approach that I usually use, is using underscores to delineate where a new word comes. So in this case, first underscore name. Okay? So we cannot use spaces. We can use numbers, but we cannot use them to start with. So we cannot do first. So for instance, if we wanted to do, let's say we use the variable name first place, like this, we cannot do that because that number is there. If we want to do this, we have to do first place like that. That's equal to, let's say, 1. So this is a variable. We're assigning the number 1 to said variable. Okay? Also, they're case sensitive. So if you do first with a capital P place, If you use it again in the future, it has to be the exact same way you describe it. So for instance, here on the screen, you say we have age equals 29, and we have price equals 35.45. Okay? They should reflect their use. So do not give me, or do not use in general, just bad variable names. Make sure you're using names that are descriptive. So if I look at the variable, I know what's actually being stored there. So if you're doing an age, don't do A equals, do age equals. If you're doing a price, don't do P, type out the word price as the variable name. Okay? Now, we'll actually talk about the different types of data. So the first one that we do have is what's called a string. A string is just a fancy word for you have some kind of quotes, either single quotes or double quotes, and they have some kind of general text in there. Okay? That's all it is. A string is just a fancy name for we have text. We denote text with quotes. For instance, if you see right here, we have name equals quotes, double quotes, Steve. That means that the string or the text stored inside of the variable name is Steve. That's it. There's no numbers, no nothing else. If we want numbers to be stored as text, we use quotes as well. So here we have date equals. That is not a number. That's not stored as a number in the program. It's stored as text. So in this case, we have the double quotes. Now, we can also replace those double quotes with single quotes as well. Just make sure you use the same ones on both sides. If you do single quote, S-T-E-V-E, make sure you end it with a single quote. Do not do single and do not mix single and double quotes. Okay? You can also use triple quotes as well to include but close both single and double quotes. But again, you're really not going to use that too often. But it is there for you to use. Okay, so let's go ahead and try this. Which of the following of these are actual valid variable names? Is age equals 30 valid? Yes, it is. Is name? Yes. Steve? Yes. 0B10? No, because it starts with 0. Underscore fave underscore hobby is because it starts with an underscore. Last space name isn't. And yes, the last one, which is just 4 underscores, is valid as well. Okay? Remember, we have our rules back here, and as long as they follow these rules, it's valid. Okay? All right, so now we actually move on to actual functionality in Python. We've used this a little bit as we've gone up here just to show off a few things, but we have what's the most basic function in just about any programming language, which is called the print function. They may have different names in different languages, but the general consensus is it just takes whatever you give it and puts it to the screen. So Python calls this function the print function, and it can take either a single argument or multiple arguments separated by commas. Okay, so down here at the bottom you see we can do print hello world, or we can do print hello comma name. Now, when we use strings, we can also format them, which goes really well with Python because when we want to format our output, we use formatting. The top one here I'm showing you, you do not have to use. I would not recommend you use it. It's the % formatting. That is the old way to do this. We don't really want to do this because, again, it's the old way. The better way is the second two. Now, you have the string dot formatting, which means that we say we have some quotes, again, some string, and we have hello, comma, and then we have curly braces. The curly braces take it and we put whatever's in the format in there. So for instance, we come over here to fully break it down. If we use the actual string formatting, it's going to be, if let's say we have a variable name, so we'll say name, we'll say name equals, in quotes, so we'll do single quotes in this case, Steve. That. Now, again, it doesn't matter whether we use single quotes here or double quotes as long as we're consistent. If we want to do print, we do print, and we can say double quotes here because, again, it doesn't matter. We can say hello, comma, curly brace, open and close, close double quotes. So this closes this double quote over here. Now we have a string in quotes, and we do dot, single dot, format. Now what we're doing with this part is we're saying, what do we want to put in these curly braces here? What do we want to put inside that spot? So we'll put the variable name. So what this is doing is it's taking the value Steve here, which is stored in name, and we're saying, given this variable name, we're going to put it in that spot. So if we actually test this, we come over here, we say name equals single quotes, Steve. Then we do print hello, comma, open, close, curly braces like that, dot format, name. So this is taking this name variable, putting it here, and this name variable holds the value Steve. So this name variable is going to, whatever's inside this, so Steve, is going to replace these two curly braces. So if I run this, it'll say, hello, Steve. So that's the first way to go about it. Now, we don't have to always print it. We can also do, we can say output equals this as well. And then we can do print output as well. We can do that as well. If we run that, it gets the same thing. But we've stored the output, this string formatting, inside of another variable. So we've combined what it was in this variable name with this rest of this string to make the output string, or output variable string. Then we print it out. The other way is we have fstring. This is the newest way. However, if you do not have at least Python 3.10, which you would have seen when you downloaded Python on the download page, you cannot use it. So if you want to learn one that will work in any Python 3 installation, just use string formatting. If you want to try something new, use fstring. So let's go ahead and actually fully try this. Let's write a program that displays the following information. We'll do it that displays our name, age, city, state, zip code, telephone number, college major, and number of years in college. So if we come over here, the first thing we're going to do with any Python program is we're going to write the following. So we'll go over this more in a later chapter, but this is the standard format, and I want you to get used to this now. So we're going to type in DEF space main, open, close parenthesis, colon. We'll go to the very bottom, and we'll say if, so if, space, underscore, underscore, NAME, underscore, underscore, space, equals, quotes, underscore, underscore, main, underscore, underscore, close, colon, then we'll do main like this, with the parentheses after it. This is what we call the standard mainline logic of a Python program. We will be using this throughout the semester so that when we get to a later chapter on functions, you guys fully have this ironed in and you don't have to worry about it, so please use this format. So how we're going to do this is, again, we want to build a function that prints our name, address, telephone number, college major, and number of years in college. So what we'll do is we'll write some comments. We'll say print out name. Then we'll do print out address. We'll do print out telephone number. Then we'll print out major. And then we'll print out number of years in college. Now, whenever you're using the mainline logic here, you'll notice that this is indented by one tab here. We want that because indentation matters in Python. So when you're writing this, make sure your code is indented one line. So what this means is, if I go to print out my name, I hit enter, tab. So we're moved over one. We're going to do print. I'll print my name, which is Dakota Vault. After that, I'll print my address. I'm not going to print my real address, but I'll print a fake one, which is 123 Woodward Avenue, Conway, SC, Conway SC 29526. Now if I want to do my phone number, I'll do print, and I'll put it as a string because a phone number is usually not something you calculate. We'll do 12345678990. It's just a phone number. You can put dashes in it if you want. It doesn't matter. It's a string, so it doesn't actually matter because it's in the quotes. Then we'll print out our major, so we'll print, we'll say computing technology. And then the number of years in college we'll print, and in this case we'll do a full number because it is a number. We'll do print, and for me it is 10. I was in college for 10 years. So if I run this now, it'll print my name, my address, my phone number, the major, and the number of years I was in college. Now this is very easy to read now because we have our comments here breaking everything up. If we want it to be more descriptive above the mainline logic here, we'll go ahead and do function that, or we can say even better, we'll say program that prints out user basic information. So now if we ever came back to this program, we would have no problem understanding exactly what this program is doing, which is what we want. Because in the future, you don't want to have to sit here and figure out exactly why you did what you did. So again, realistically what we learned here was make sure you use the mainline logic function. It's a best practice. You will be using it in the future, so it's best to get used to it now. So please get used to it now. When you use it, all the things you write inside that function should be, with the mainline logic, should be tabbed over once. So when you put something else in there, make sure that you hit enter and then it'll either tab for you. If you're back here, make sure you just hit tab once to move over. Okay? Make sure you put your comments as well, because again, that's a good practice to learn now, because in the future you will need that. And as you go ahead and use these print statements, you will see that you can print out everything you need. Okay? All right, so moving on, so we've talked about strings a lot now, but we can move on to different types of data. So in this case, we're going to be talking about numeric data types. So specifically, we've talked about strings already, which are used for storing text in memory, but we can also use int, which stands for integer, for storing whole numbers, so like 1, 2, 10, 55, 131. Those are all integer numbers. We'll use the int for that. And for decimal values like 3.5, 2.2, stuff like that, we'll be using float. Float stands again for that floating point standard format that we talked about in chapter 1. Now, we don't have to worry too much about declaring these data types. It's just important to know that we have them, because Python will automatically set a variable for the data type that we give it. But if we need to change data types, we need to know what we're trying to change it to. So I'll go over that in a second, but again, a numeric literal is what is the number written into a program. So back in the one we just built, when I put the number 10 in, that right there is a numeric literal. It is just a number we put into a program. So when we go to reassign a variable, again, we can reassign variables with to different names. So I can change a value. So if I have, let's say I come back over here and I have a variable, let's say named, I come back in here, we want our mainline logic still, and I'll say name equals Bob, which is a string, and then I say name equals Sue, and if I print here, so if I print name here, and then I print name here, you'll see that when I run this, it'll print Bob first, because it goes from top to bottom, so we'll say name equals Bob, we'll then print Bob, then we say name equals Sue, and then we'll print Sue. Because again, when we do name equals Sue, it overwrites what was in name before, so it will get rid of Bob, and it'll replace it with the new value we give it. Now, when we replace something, or if we don't no longer need an actual variable, we have what's called garbage collection. So instead of wasting the memory that's there, we don't need it anymore. So the Python interpreter will automatically say, you don't need that anymore, I'm going to take care of it, I'm going to get rid of it for you. Okay? So again, in Python, unlike other languages where you have to be very explicit in what data type you're doing, in Python, any variable can refer to any item of any data type. Okay, so that's good, which means again, Python is going to automatically choose. So if you give it the number 10, it's going to say that's an int. If you give it the number 5.2, it's going to say that's a float. And if you give it something in the quotes, it's going to say that's a string. Okay, and we'll talk about different data types as we go, but again, Python is going to automatically choose those for you. Okay, so again, here's another example. If we have x is equal to 99, so if I come over here and I say x is equal to the numeric literal 99, I can then print x. Then if I say x is equal to hello world, and then I print x, and I run this, wrong button. If I run this now, it'll say x, the first line here on line 4, is saying x is equal to the number 99. So x is now an int. The variable of x is associated with an int value. I print that int value with x. Then I say now x is associated with a string value, and then I print the string. Python automatically changes x from a int to a string for me, so I don't have to worry about that. All right, so now we know about the print function, so we know about our output. So we're going to be using the output function to print anything to the screen that we want. But again, there's a 3-step process with computers where we input something, process it, and then output. So what we're going to be using to read input from the keyboard is we're going to be using what Python calls its input function. So the input function is written as such right here, where we have a variable is equal to input with some kind of prompt. The prompt is usually a string that instructs the user what type of value that you want them to enter. So again, the input function will always return as a string. So for an example here, if I come over here and I say age, or let's actually say name, is equal to input, so we have our input function, and we say enter your name. Put a space after just for extra formatting. You don't need this, but it looks better if you do. Then if we print name, what's going to happen when we run this is Python's going to say enter your name. When I do this, you'll see I can click down here now, and what's going to happen is Python is going to sit there and wait until I put something in. So if I put in my name as Dakota, and I hit enter, it'll print out what I give it. So it took what I gave it, stored it in name, and then printed out name after that. Now, the input function only returns a string. So if we want to make sure it's a number or a decimal, because different operations work differently on different data types, we need to make sure we use what's called a cast or a convert function to convert it to an int or a float. So for instance, if I come over to here, and let's say I wanted to do name equal, or let's say we do age equals input enter your age, and then I wanted to print you will be, we're using string format here, so we'll do the curly braces next year, and I want to dot format, I want to print out their age plus 1. So what they'll be next year. So if I run this now, it's going to say enter your age. So if I say I am 28, it's going to give me an error. Now you'll see right here it says it's a type error, so this is a syntax error, and it says you can only concatenate string, not int to string. So the problem with this is that input here only returns a string. I'm trying to add 1 to that string. If I want age to be an int or an integer, I need to put int, or actually I can do this. I can say age equals that, and I can say age equals int of age. I can do it that way, and what this will do is it'll first get the input stored in age, then I'm going to take the age, what's ever stored in the age, so that's a string now, I'm going to convert that to an integer, store it back in age, and then I'll do this, and I'll print it out. So if I do this now, I do 28, it'll say you will be 29 next year. Again, note, I said you will be curly braces next year, so again, age plus 1, it does this computation, and whatever is here in these two is stored where these two, or is printed out where these two curly braces are. Now you can use what's called a nested function call right here, where we actually can combine those two lines. So you'll see right here I have our input and our int. I can take this line and move it up here by doing int and putting parentheses around input like this. So what's going to happen is, this is called a nested function call. You can do it either way you want. You can have them on 2 separate lines or on 1 line. And what's happening here is it will call input first. Input returns from the function call. It returns a string. That string is then passed to the int function, which takes a string and converts it to an integer, which is then stored in age. So it's a shorter way to write this. Now, if you don't want to do this, you can do it this way as well. There's nothing wrong with that. If it makes it a little bit more clear, go ahead and do that for now. In the future, you guys will work with, using nested function calls. You will use them in the future, but for now, if this makes it clearer, go ahead and just put it on different lines each time. But that's what's called a nested function call. All right, so let's actually fully break this down. So let's say, so this is again chapter 2, problem 1, and we're going to write a program that asks, not just takes, but asks the user for the following information and displays it. So what we're going to do is we'll come back over here, and we're going to take, and we're going to say, again, make sure we're indented correctly here inside our mainline logic function, and we're going to ask, and we'll say name equals input, what is your name? Then we'll say age, or actually we'll do name, and then I think before it was Yeah, address. So we'll say address equals input. What is your address? Then we'll have phone number, and we'll say phone equals input. What is your phone number? Again, we're not making phone number here into an integer or a float because we do not want to use any kind of math on it, so a string is fine. After that, we'll say college major. We'll say major equals input. What is your college major? And then we'll have years underscore in underscore college equals, again, this is now a number, so we'll do int input, or again, we can do input how many years were you in college? And then we can do years in college equals int of years in college. Now after we have that, we can have a comment up here saying get user info. Then we can come down here and we can print user info. So now we can come down here, we can do print name with a colon, curly braces, dot format. We'll put name here, so we'll print the name out with the word name in front, followed by the name. We'll do print address, colon, dot format, with address after that. And you can start to see a pattern here where we do print phone, colon, dot format with phone. Then we do print major, colon, curly braces, dot format, major. And then we can do print years in college, colon, dot format, years in college. So again, we're using the string dot format approach on each one of these to take the variable that we give it and put it where the curly braces are. So if we run this now, we'll say what is our name, so we'll put our name in. What is our address, so we'll do 123 Woodward Avenue. We'll just leave it for that right now. What's the phone number? We'll do 123-456-7890. Then we'll do what is your college major? We'll say computing technology. And we'll say 10 years here. When we run that, you'll see we have our name, address, phone, major, and years in college. So we took the information we had from these input functions, stored what we gave it as strings in each of these. On the years in college, we took the string that was stored in it and converted it to an integer and stored it back in the same variable. So we took that variable from a string to an int. Then we printed everything out as different strings using the string.format approach. Okay? So now if we want to go even further, because again, we can take input, we can print it out, but we need to do the process. We have input, we have output, we don't have processing. Okay? So now to do processing, we're going to be doing different math calculations. So specifically, we're going to use these different math expressions. So in Python, we have multiple ones. We have plus for addition, minus for subtraction, a star, which is usually on the 8 key. So if you do Shift 8, you'll see the star key. We have our divide sign, which is on the question mark key. So if we do Shift question mark, or I'm sorry, just the slash key, where it's rather slash and question mark, you can do divide. And then we have the double slash for integer division. Now, with these, we have our math operators and we have our operands. So if we want to do 2 plus 2, the 2 and the 2, the two different 2's that we have, or 2 plus 3, the 2 and the 3, are our operands. The math operators in the middle, and the results are usually assigned to some type of variable. Now, again, as I was saying earlier, there's two different types of division. We have our floating point division, which is just a fancy way of saying if we do 5 divided by 2, we will get 2.5. Okay? If we do integer division, it's going to say instead, it's going to truncate it. So again, it's going to truncate it to a whole number. Okay? So again, these divisions have nothing to do with the different data types. It is only about whether it's going to be a decimal with this floating point division, or it's going to end as an integer, which is integer division. So if I'm doing a float, double slash, a float, it will end in an integer division. If I do an int slash an int, it will end in a floating point division because I'm either using the single slash or the double slash. So again, it just depends on whether you truncate the results or not. Most of the time, you will be using the single slash approach, though. So with Python, just like with math, we have an order of operations. So the way that this works is Python reads every line from left to right. So whatever you put first, it's going to read that first on that line and perform that math first, followed by the next one, next one, next one. The only exception is when we do the order of operations. Just like with math, the first thing it does is anything that's enclosed in parentheses, it will do first. Followed by that, if we want to do an exponent, so if we have like 2 to the 3, in Python we can't do that, so we have to do 2 star 3, which is the same thing as 2 to the 3. So for instance, if we wanted to do, if we come over here, let's just do this actually. If we want to do 2 to the 3rd in Python, that's equal to 2 star 3. So that's how this is how we write this in Python. Okay? So we have our exponents, then we have multiplication, division, and what's called the modulus operator or the remainder operator, which we'll cover later. But again, that's just a fancy operator for saying if we have, so the modulus operator would be saying if we have 5 mod 2, 5 goes into 2 times, which is 4, with a remainder of 1, so this would equal 1. Okay, so we'll go over that more in a second, but that just takes the remainder of the division between the two numbers. So again, this is the order they go in. So it goes in parentheses first, then exponentials, multiplication, division, remainder next, and then finally addition and subtraction. So again, just like with any other kind of math, the higher precedence is performed first, so parentheses first, exponents, and so on. So again, like I said earlier, we cannot just always represent something directly like we would in math because we have syntax rules. So for exponents, if we want to do x to the y, just like we did 2 to the 3, we use x with 2 stars, and then the actual exponent we want to raise it to. So it's x star y. The modulus operator is a very useful operator that returns the remainder. So for instance, if we want to see does 4 divided by 2, does 4 go into 2 evenly? If that's the case, we do 4 mod 2, and if that's equal to 0, that means there's no remainder, so it's an even division. Okay? Same thing there. If we do 5 mod 2, 5 goes into 2 times, because that's 4. And then after that, we have 1 left over, so it equals 1. So again, they do not go directly into programming. So you'll need to do some kind of translation between your math formula to programming for you to actually put math formulas in programs. Now, with that being said, you also may need to add different operators or insert parentheses as well, because again, order of operations matter, and me and you can understand that if something divided by something is supposed to be written done this way. Python doesn't know that unless you put parentheses there, or you add a multiplication operator. So let's go ahead and try this. So if we have this first one here, how we write this follow program? So we have 4yz. Okay. Again, we can't do that because Python doesn't know that you're multiplying them across. So instead, we're going to do, for that one, if we do this, if we have 4yz, this is going to go to 4 star y star z. Okay? So that way Python knows you're multiplying 4 by y by z. These are 2 different variable names, and this is a numeric literal right here with the number 4. Okay? So there you see we have that right there. After that we have a plus b divided by c. Now we know that we'll do a plus b first, but Python doesn't. So what we'll need to do is we'll do a plus b divided by c is going to go to a plus b slash c, but because we need to do a plus b first, we'll put parentheses around this. So that way Python knows to do a plus b first and then divide by c. After that, we'll see we have negative y times z over 2. So if we do that, we'll have negative y z over 2. That's going to go to negative y, like that, times parentheses z divided by 2. So we want to make sure we do z divided by 2 first, then multiply that by negative of this variable. So we have, again, a variable, and a numeric literal. So we have negative y times star z divided by 2. If we go down here, we have 3cd to the third plus 11f. So up here we have 3cd to the third plus 11f. So let's break this down. We'll do this first side first. We'll do 3 times c times d star to the third. Now, Python will recognize this usually, but I like to put parentheses around this just to really make sure that it gets that done first. Then we do plus 11 times f. So what's going to happen is Python will do the d to the third first because it's an exponent, and it's in the parentheses, so we'll do that first. Then it will do 3 times c times that result, and it will also do 11 times f. Then we'll add those two results of those two together. So it's going to do all of this here first, and then it will do this here first as well after the exponent's done. Then it will take those two and add them together. So again, we have 3 times c times d to the third plus 11f. Lastly, down here we have ay plus b divided by c minus dz. Just like before, we're going to have a star y for ay plus b. We put all of that in parentheses because we want to do the top first, and then we're going to do the bottom and then divide the two. We'll do divide by, again, in parentheses, we'll do d star z, we'll do c minus that, and now we have our answer. Okay, so again, remember that you cannot just put direct math equations into Python. You need to convert them into something that's readable with the syntax rules. All right, so if we go further, we have, again, what's called mixed type expressions and conversions. So if you're doing some kind of math on ints or floats, it changes depending on what you're doing. So what this means is, if we have two int values and we do addition on them, subtraction, multiplication, or division, or should I say, let's really realistically here, if we have two int values, we're going to get an int. If we have two float values, we're going to get a float. Okay, so what I mean by that is, if I do 5 times 2, that's an int times an int, it's going to give me an int. If I do 5 plus 2, it's an int. If I get 5 minus 2, it's an int. Okay, same thing with a float. If I do 3.5 times 1.2, it's going to still be a float. Now, if I do ints and floats, we need to convert everything to a float because, again, remember, we have that IEEE 754 floating point standard. If we can convert ints to that standard without losing any information. However, if we convert a float to an integer format, we will lose all of those decimal places. So during that operation, when we use ints and floats together, the int is actually converted to a float temporarily so that the math can actually occur. Now, the only other actual caveat to this is, again, if you divide two ints, it will give you a float back as well. But if you're doing any kind of addition, subtraction, or multiplication between ints, you get an int. If you do addition, subtraction, multiplication by a float, you get a float, and so on. So now what we can go on to is, these math equations are going to get very long. So instead of trying to write them on one really long line, we can use what's called a multi-line statement to shorten them. So instead of having, let's say, if we come over here to our code, instead of having, let's say we have math equals a times 3 plus b times 2 plus 123 minus 5, and then we keep going, we'll say plus a plus a plus a plus b plus num1 times num2 times this divided by that. If this equation keeps going, eventually you'll see it's going to get to this side and it will no longer be visible. So if I keep going and if I say plus this underscore is underscore a underscore long variable name that I have, so pretend that's a variable name. Now you can see that we can see this entire equation here. What we can do instead is we can use called a backslash character and hit enter, and now we have it all on the same page again. Now this doesn't make any sense because these variables have not been declared before, so we can't use them before they're declared. But you get the idea that we can use this backslash character here to do that. Now, the other way we can do it is we can also use parentheses as well. So if I change this back here from, instead of that slash, I just use parentheses at the beginning and a parentheses at the end, I can get rid of this backslash here, and it still knows because, again, Python, if it sees a parenthesis, will go until the very end of the parenthesis as well. So it will find the other side. All right, so here's an example. If we say value plus 1 plus value 2 plus value 3 plus value 4, instead of having one long line, now we can break it into 3 lines. It still works as one line, but it's easier to read for us. All right, so a little bit more on the actual data output. We've talked about the print function as well. And if I come over here, let's go ahead and get rid of this junk here, because again, that doesn't actually work. But if I want to print multiple things, I can also do print hello, comma, world, like this. And I'll go ahead and get rid of this because we don't need this right now. If I do this, it will print, got the colon there, it's a syntax error, so I'll go ahead and rerun this. It'll print hello world. Or I can say hello good world. And it'll print hello good world with spaces in between. Now, the print function has different actual arguments that we can do. The first one is called end. So what we can do is it will change how the print function actually ends. Now usually, if I print one thing followed by another thing, so if I come over here and I do print that, and then I print this is another line, like that, you'll see that the first one up here, this guy, is going to end, and it will enter down to the next line for the next print statement. If I don't want that, I can do comma end equals, you'll see it changes colors, and then in here I can put a quotes here, and I can put a colon after that, or anything else I want in there, and instead of a new line, now it'll put a colon instead of a new line, which means it'll keep it on the same line. So over here you'll see another example. I put a colon, and then I put nothing. So I print 1, 2, 3 with a colon between the first two and nothing between the second two, so it does 1, 2, 3. So again, you can play with that as you want, but again, you usually use end equals with something inside of quotes. Again, single or double quotes, they don't matter as long as you use one or the other and you're consistent. So there's another argument as well. It's called the separator value. And as I said earlier, this already, if I get rid of this other line here, so I'll just do 3 quotes here. So now we have 3 quotes. And over here, you'll see it gives you a space and another space down here at the bottom. If I wanted to change that, I could do SEP equals, and let's say in between each of them, I want to put 3 spaces. So I'll do 1, 2, 3. So now if I run this, I'll get 3 spaces. So 1, 2, 3. So in between each of them, I have spaces. If I want to make this a little bit more visible, I can do PPP. Run that, and now in between each of them there's P's. If I want to do star, 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 now you'll see that there's 3 stars between hello, good, and world. So you have full control when using the print function of between what comes up between, if you use commas, you can change how it separates. If you want to do multiple print statements, the one you'll use more often in this case is end, and you can change whether it goes to a new line or what it puts in between. Okay? So one other thing to keep in mind is that when you're using the actual data output, we have special characters as well. So we have special sequences that are escaped out inside of strings with a backslash. So what this means is if we use \n or \t, it changes. So for instance, if I come over here, let's go ahead and simplify this back down again. And I say, instead of this, I want to say this is another \n. It's actually going to put 2 new lines, so it'll enter down from this line, enter down from this line, and put line on another word, on 2 lines down. Because each of these \n's is a new line character, so it's another, basically you hitting enter. If I want to put tabs, I can do the same thing. I can do \t. I can do multiple of those, so that's 2 tabs. And now this pushes it over by 1 tab. So you'll see right here we have 1 tab going there, that's 1 tab, and the second tab is right there. So remember, tabs are equally spaced, so they will vary in size, but again, the \t is very helpful for lining up output. Okay, so again, you can also concatenate two strings as well. So if you see right here, we have the hello in quotes plus world in quotes, which will equal out to hello world. Okay. So let's go ahead and explain this right here. So how do we actually suppress the print function's ending new line? So we do this by using the end attribute, or the end argument. So what we can do is we can do end equals, and in quotes, we can put anything else we want. If we do end equals empty quotes, it will just have no new line, nothing else after it. If we want to put a space after it, a comma after it, we can do end equals quotes, comma. We can do that. Now, how can we actually change the character that's automatically displayed between multiple items that are passed to print function? Just like when we use end, we can also use the separator attribute or the separator argument. If we go down here, we can say, what is the \n escape character? That's a new line character. What is the \t escape character in strings? That's a tab character. And what is the \/ escape character? That is just a backslash. So if we want to actually use a backslash in a string, we need to do \/ instead of just a single backslash. All right, so we go on ahead and we'll go ahead and start talking about formatting numbers. So again, when we're working with money, we know it goes out to 2 decimal places. When we're working with, let's say, pi, we want to go to more decimal places and so on, but Python allows us to also format these numbers. Okay, so we can do this using the actual built-in format option with the string.format function. We have that option. So for instance, right here, if we look at these, again, the first one's just there for your reference. Don't actually use it. Use instead the string.format or the f strings. Now you'll see here we have a :2f for formatting, and that's going to put, the colon says we're formatting it, the dot means we're doing a decimal, 2f, which means 2 decimal places of a float, which means it's going to give us, instead of 3.1415926, it's going to give us just 3.14. Okay? So we can go into actually other options here as well. We have our comma separator form. We're using the f strings here. Again, you can do the string formatting as well. So what I mean by that is if I come over here, and if I want to say print, use the curly braces, and I want to dot format, let's say the number 1000, or let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And I want to use it in the comma, so I want commas between the numbers. I can do : comma. If I run that, it now gives me 1,234,567,890. So you'll see that the : comma puts commas there. Again, you have the percent format, so if I want to do a percentage, I can do 0.92. Again, percentages in Python are stored as decimals, and if I want to use a percentage, I can do : %. And that will multiply it by 100 for me, assuming that it's stored as a decimal, and give me 92%. Now, if I don't like how many zeros are here, like if I do 9215, maybe I just want 2 decimal places, so I can do : .2%, and it gives me 92.15. Okay? So I can also do scientific notation using : .2e, which gives me 2 decimal places with the exponential. So in this case, we have this large number. It'll give me 1.23 e to the +04, which is the same thing as 1.23 times 10 to the 4. And we also have integer form as well, which just makes sure we're printing out an integer. We have more here as well. So those were the actual formatting of the actual numbers. If we want to actually format the actual display, we can use the minimum field, which is a colon and then a number. So in this case, it's :6. So if I do number, colon, and I do : 6.2%, if I run that, you'll see that there is now 6 spaces. If I do 10, there's now 10 spaces. So this takes up 1, 2, 3, 4, 5, 6. And I have another space up to 10 over here. So that helps me actually organize the actual field width. I can choose to left align using the caret, right align using the other caret, or I can center align it using the upper caret. I guess we have less than symbol, greater than symbol, or the actual caret. It allows you to choose how you want to center it. Now, the way you use these is you have to use alignments, which are these, the less than, greater than, or caret. You have to put that first, followed by the width, so 6, 10, whatever we want to do. Then a dot with the precision that we want. So if we go back here, we have our .2e, we have our .2f, the precision is the 2. So over here, our precision is 2. If we want to change this to, let's say, 4, We can run that now, and we have 192 or 92.1500%, so it's a precision of 4. Then after that, we have our type. So that's going to be either the D, it's going to be the percent, the E, and so on, or the comma as well. Okay? So we have all those different ways that we can format numbers as well. Now, as we're going off of numbers, one thing I want to bring up is magic numbers. Do not put just random numbers in your code, okay? Use variable names so that people know what numbers are. So like if I ask you guys right now, what does the number 0.069 actually mean? So if I have amount equals balance times that, is that a interest rate? Is it a fee percentage? The only person that's going to know that is the original programmer. Again, we use comments to make this code more clear, but we can also use variables to make it very clear as to what each value is as well. So the problem with those is, again, it's difficult to determine the actual purpose of the number. If it's used in multiple places, so if you use 0.069 in many different places, then if you ever change that to, let's say, 0.071, you have to go through your code, and if we have a really large program, it might have multiple files, and you have to find every instance of 0.069 and make sure you change those. Also, if you make a typo, so if let's say it is an interest rate and it's 0.069, but then you somewhere type 0.0069, you're costing somebody money. Okay, so they're not going to be very happy about that, and they're going to find out it's you. And if they find out it's you, you're going to get in trouble with your actual software development team, your lead, or whatever you want to do. So what we can do instead is we can use what's called named constants. So named constants are saying we have a number that we know is not going to change during the actual program's execution, and we use that and we make that, and the only time you'll ever use all capital letters is with named constants or just constants in general, and we'll use all capitals to denote that that number will not change throughout the program. You can change it, but you should not. So do not change it through your program. Again, Python's not going to stop you, but don't change it if you use all capitals. So in this case, if we change it, now we say interest underscore rate, all caps, is equal to that. So now we know that we have our interest rate as a number that's a constant. So the actual advantages of named constants is, again, it makes the code very self-explanatory. It makes it easier to maintain and change. And the named constants help prevent typographical errors so we don't accidentally type it wrong. So just in total, just do not use magic numbers. All right, so let's go ahead and try this here. So what this problem says, it's 2-4 and 2-6. I sort of put them together. And it says a customer in a store is purchasing 5 items. And what we want to do is we want to write a program that asks for the price of each item, then computes the state and county sales tax. And we want to assume the state sales tax is 5% and the county sales tax is 2.5%. The program should then display the amount of each item, the total amount of the purchase before tax, the state sales tax, the county sales tax, the total sales tax, and the total of the sale. All right, so let's go ahead and give this problem a shot. So what we're going to do is we're going to first ask the user, so we're going to ask the user to enter the price of 5 items, because that's what the problem asks us to do. So over here you'll see it says write the price for each of the items for the first 5. So we'll say item underscore 1 or item 1 equals input, enter the price of item 1. Then we'll say item 1 equals float of item 1, which will cast it to a floating point number or a decimal number. And then we're going to copy this 5 times. We'll do it again, 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 again. So we'll do item 1, change this to 2, item 2, 2, 3, 3, 4, 4, 5, and 5. Make sure you change it over here as well. We'll do 2, 3, 4, and 5. Okay. So now that we have our 5 items, we then need to come over here and it says compute the state and county sales tax. So we're going to assume the state sales tax is 5% and the county sales tax is 2.5. So what we're going to do is outside of the main up at the top, we're going to make our constants. We'll say constants, and we'll say state tax equals this, and county tax equals this. And so it said the state tax is 5% and the county sales tax is 2.5. So we'll do state tax is 0.05, which is 5% in Python, and the county tax is 0.025, which is 2.5%. So now we can use those. So now we'll calculate the total. So we'll do total equals item 1 plus item 2 plus item 3 plus item 4 plus item 5. Then we'll calculate the tax. So we'll say, we'll do county equals total times county tax in all caps. That refers, so this is referring to the value we declared outside of the mainline logic. And then we'll do state equals total times state tax. And then we'll say grand total. So over here we'll actually calculate tax, and we'll calculate grand total. So the grand total is equal to the total plus the county plus the state. Like that. So then after that it says that it wants us to display the amount of each item, the total amount of the purchase before tax, the state tax, the county tax, the total sales tax, and the total sale, so everything. So we're going to go ahead and display everything. So we'll go ahead and print item 1, the curly braces, .format item 1. We'll copy that line and we'll just repeat this for all 5. So 2, 3, 4, and 5. Come through each of them, 2, 3, 4, and 5. We do 2, 3, 4, and 5. Then we'll come down here and we'll do state tax. It's equal to state, not the rate, but the one we calculated, so that's state. We'll do the same thing for county tax. Again, the one we calculated, not the actual full tax, but the one we calculated. So again, it's county and state. Then it also wants the total tax, so we'll have to do total tax here is equal to county plus state. So we'll come down here and we'll do total tax, and that's going to be total tax that we just made. And then we'll finally print the grand total, format grand total. So now if we run this, it's going to ask us for the first price. So we'll do $12.75, $1, $13, $15.05, and let's say we do $31.20. So what's going to happen is now we have our items right here. We have our state tax, sales tax, and our total. Now you notice that these don't actually look good, so what we're going to do is we're going to use the print formatting. So we'll do :.2f, because that makes it actually like a dollar amount. And we're going to go ahead and put a $sign out front to make sure it's denoted as a dollar. So we'll copy all of that, and everywhere else we see the curly braces, we'll just go ahead and replace that because we're using money for everything. Just like this. Place it there, place it there, place it there, place it there. So we can run that, just enter through it real quick just to make sure it works. So we have $1 for everything, state tax is 25 cents, sales county tax is 12 cents, grand total is that. If we make this look even better, we could even go a step further and use tabs. We can do / tabs, which will tab things over twice. Do that for everything. Make sure you do the / character sequences inside of strings. You do it down here as well. And you can play around with this as you go, because you'll have to in programs just to make sure things look right. Run this now, do ones again. So you'll see that this still doesn't look entirely right, so we need an extra /t on these to push them out a little bit further. Just like this. And then we need one last one here to bring it in one. So if I run that now, with all the different numbers, now everything's lined up. So again, you can play with this as well. I mean, again, the tabs you just sort of figure out as you go. There's no rhyme or reason. You just keep tabbing them or untabbing them until everything lines up. But then when you're done, everything will line up nicely. So that's how we're actually going to work on this one. That's the same as 2-4/2-6, a little bit of both of those. Now, as we go, we're going to be talking about the actual introduction to Python modules. So as we go, everything that we want to do is not always included in Python. So how we're going to solve that is we're going to use Python modules. Because these are a lot of features that we can use a lot and we will need a lot, but they're not pre-installed or pre-included in Python. So a few examples of them are things like NumPy, the scientific computing and math tools library that you may use in the future, Pandas, which is for matrix data and tabular data, Matplotlib and C1, which is for data exploration and visualization, so if you want to make nice graphs. And if you want to do machine learning, you use the scikit-learn. And then lastly, if you're doing anything with websites, you can use urllib3 to help with HTTP requests. So one of the modules we're going to be using in this class to sort of just get us familiar with libraries and modules in Python is what's called the turtle graphic. So Python's turtle graphic system displays a small little cursor known as the turtle. It actually comes from one of the larger schools who actually built a little turtle robot that had a pen and would draw on paper as the students programmed it. So now we have just a more virtual or digital representation of that turtle. So we can use Python statements to move that arrow around. So the first thing we have to do when we do anything with modules is we do an import statement. So for instance, if we go back to our actual example, we're going to come up here and get rid of what we had because we don't need that right now. Again, for you, what you should be doing is you should be making new files each time. So for instance, if you wanted to keep what we had here, so we keep everything the exact same way, what we can do instead is we can right-click over here, do New Python file, and we'll say turtle. We'll hit OK. And now we have our turtle here. If we need to, we can drag it out to here. Or not. Okay, either way, it doesn't really matter where it's at too much as long as you can keep track of the file. So we'll do our main line logic. So we'll do def main, like that. And then we'll do if underscore underscore name underscore underscore equals quote underscore underscore main underscore underscore colon. We'll do main there. So this is our main line logic. And if we want to do the turtle, we're going to do up here at the very top, we'll do import turtle. So that's going to bring in the turtle functions and the turtle library calls that we can use to actually run with the turtle. So with this being said, after we have the turtle imported, the next thing we can do is we can use what's called turtle.forward. So turtle.forward allows us to move the turtle forward. So here you'll see we go from here and we move 100 pixels forward. We also have turtle.right and turtle.left, which we can turn the turtle left and right. So here you'll see we can do turtle forward, turn left 90 degrees, and go forward again, so now we have a right angle. We have the same thing here, but we have forward, right 45 degrees and 100, so now we have a 45-degree angle right here. And then we can also set the turtle's heading as well using .setHeading here. So we can do forward, so we go forward 50, set heading to 90 degrees, so 90 degrees is up. Forward, we can set the heading to 180, which is over here to the right, to the left. Forward again, and now we're back down the where we were at the beginning. Now we can also bring the pen up and pen down. So if we don't want to draw a line, we can use pen up and pen down. So here we can do, you'll see we can do forward 50, dot pen up, forward 25. So the smaller 25 is the one that you can't see, there's no line there. Put the pen down, do another 50, pen up, do another 25, down, do another 50. So that's how you can make dashed lines. We can also draw circles with the turtle.circle here. So we draw a circle with a radius of 100 pixels. We can also draw dots as well. If we do turtle.dot, wherever the turtle is, it'll just leave a dot behind. And we can also change the pen size and draw colors as well. So we have turtle.pen size with a width and turtle.pen color with a color. We can also change the actual color of the turtle's window with turtle.background color, turtle.setup as well. Again, all of these functions are there for you. We'll go through them here in a second. And we can also reset the turtle. Now, with this being said, you're going to make sure you use the correct reset. So before you try to reset the turtle's window in any way, make sure you come back to this slide to understand it, because turtle.reset will erase all your drawings. It'll reset your colors, reset your location, but it does not reset your background color. Turtle.clear erases the drawings, doesn't reset anything, any of the settings, but turtle.clear screen erases the drawings and resets all the actual settings. It's a little bit confusing, but if you do need to use the actual reset functions in any way, make sure you come back to this slide with the actual slide deck and look back over this. So again, when we're working with the turtle as well, we are also working with coordinates. So just like a Cartesian coordinate in math where we have our x and y's, we can pick up the turtle and put it anywhere we want. So we have turtle.goto, and we can take it and put it at that spot. And if we want to know where the turtle currently is, we have turtle.pos for position. We also have turtle.xcore and ycore to give us its x and y coordinates. So again, here you'll see we import the turtle. We have goto, goto, goto. So we start here, and then we go to 0, so 0x, 100y, so it moves it here. We go to negative 100x, 0y, so it goes diagonally here. And then we go back here, so now we've made a right triangle. So we also change the speed of the turtle. So as the turtle draws, if we want it to go the normal speed, we leave it alone. If we want it to go instant, we change it to 0. And if we want to go really fast, we change it to 10. If we want it to go really slow, we change it to 1. We can also hide and show the turtle, which just changes whether you're showing the arrow or not. And lastly, we can also display and write text on the turtle screen as well. So here we can say wherever the turtle is, we can just write the word hello world and it'll print that on the screen. Lastly, we can also fill shapes. We can do begin fill, end fill. So here you'll see we have our hide our turtle, so we don't have the little arrow anymore. We can fill color red, begin the fill, make a circle, and then end the fill, which means that whatever we just made, whatever shape we made, it will change it and it will actually fill it with the red color. So after we're done with the turtle, the last thing we need to do if we want to look at the actual drawing is we need to make sure we have turtle.done, which will keep the graphic window open. All right, so now that we've seen the commands, what I want you guys to do is I want you guys to go ahead and give these ones a shot on your own. So again, if you guys go back through and try them out, you'll see that we have these different options that we can use. But again, this is good practice for you guys to just try them out. Now, in summary for this chapter, what we've covered is we've covered the program development lifecycle, tools for program design, and the design process. The ways in which the program actually can receive input, and particularly from the keyboard. We've also talked about how we can present and format output. We've talked about how we can use comments and why they're important. We've talked about variables and why we should use named constants. And lastly, we've also talked about the tools for performing calculations of programs and the turtle graphic system. So that is all for Chapter 2. And in the next chapters, we'll actually start going on into more of the logical structures of programming languages, as well as more of the basis level understandings for them as well. Thank you.